Properties of exponents. We're going to talk now about the different properties that we have of exponents. The first exponent is the easiest one probably, is the zero exponent. And that one just means that any number or anything to the zero power is just going to be 1. So that means negative 3.14 to the zero power is 1. And we could put any number in here. We can say 27 to the zero power is 1, or 1,000,000 to the zero power is 1. The whole point is anything to the zero power is 1. So if we want to do an algebraic example, we could just say x to the zero power is 1. So any number x to the zero power is 1. So there's your general rule. The next property is the negative exponent. The negative exponent means we're going to flip the exponent over. Okay, so what I mean by that is negative 5 to the negative 3 power is equal to 1 over negative 5 to the positive 3 power. We want to get rid of the negative exponent. And then we can actually just type that into the calculator because everything is positive, so we would have 1 over negative 125. If it's a kind of small number, then go ahead and compute it out, but if it becomes a large number, don't even bother with that. So then that would be our final answer. So flip it over the fraction bar. And then you just simplify. Okay, so this next one, we basically want to go backwards. So if we flip this over the fraction bar and then added a negative, then we would have 7 to the negative 2 power. And that would be the same thing. We just worked our way backwards. We flipped it back over the fraction bar and then added the negative. When we flip it, so this is my first rule, flip the exponent over the fraction bar. The second rule is that you drop the exponent. Or sorry, drop the negative. Alright, now in general, our algebraic rule for this would be x to the negative y power, doesn't matter what it is going to be equal to 1 over x to the y power. Or if we have 1 over x to the negative y power, same thing. If we would work backwards, we would flip that because it's a negative sign, flip it over the fraction bar, and we would have x to the positive y power. Okay, so those are both the same thing, and they're the negative exponent rule. Product of powers. Okay, so the product of powers rule is going to be when we're multiplying two different powers that have the same base. So 4 to the 5th power times 4 to the 3rd power is going to be 4 to the 5 plus 3 power, or 4 to the 8th power. And the next one, negative 3 to the negative 2 power times negative 3 to the 9 power would be negative 3 to the negative 2 plus 9 power, which is equal to negative 3 to the 7th power. Alright, and finally our algebraic rule is if we have x to the m power times x to the n power, we're going to have x to the m plus n power. And then we're done. So that right there is your algebraic example. For the quotient of powers rule, it's very similar, except instead of adding, we're going to be subtracting. So if we have 4 to the 5th power divided by 4 to the 3rd power, we're going to have 4 to the 5 minus 3 power, which is going to be equal to 4 to the second power, which that one's small enough we could write it as 16. Okay, and the next example we have negative 3 to the negative 2 power divided by negative 3 to the 9 power, so that would be a negative 3 to the negative 2 minus 9 power, which is negative 3 to the negative 11 power, but we don't like negative exponents, so we're going to get rid of that, equals 1 over negative 3 to the 11 power. That's our negative exponent. So we put two things together. This had a negative exponent, so we had to get rid of it. So we got rid of it by flipping it over the fraction bar. And my algebraic example is if we have x to the m power divided by x to the n power, we get x to the m minus n power to put them together. Keep in mind my base x has to always be the same. So that's your algebraic example. Okay, so for the next property, we have the power of powers property. So that means when you have like 2 cubed, or a number to a power, and then there's a power on top of that. So if we have 2 cubed to the 6th, so how we would solve that, we would take 2 to the power of 3 times 6. So you're going to multiply the powers. So that's going to be 2 to the power of 3 times 6, which is 18. So 2 to the 18th power, and that's your final answer. The next one, we have 2 to the negative 2 power, all of that to the 5th power. So that's going to be 2 to the negative 2 times 5, which is equal to 2 to the negative 10, but now we have a negative exponent. So because of that, we need to get rid of that negative exponent, so we flip it over the fraction bar and get rid of the negative. So we have 1 over 2 to the 10th power. And that's your final answer. So for the algebraic example, we would have x to the power of m, all of that to the power of n. So if we wanted to put that together and simplify it, we'd have x to the power of m times n. And that would be your final answer. And there's 2 more properties here. The power of products is the next one. So the first thing, we can do this 2 ways. We can go 2 times 3 times 4, which is 24, and then go to the 5th power. So that's fine. That's one way to do it, but that's only if it's numbers. So that won't always work. So how we want to think about it here is we put the 5 in with each part. Since they're all multiplied, we can put the 5 in. So it would be 2 to the 5th power times 3 to the 5th power times 4 to the 5th power, which is also equal to that 24 to the 5th power. So either way of these is technically correct. So the next one, we have negative 2 times 4 to the negative 2 power. So there's 2 ways to do it. We could go negative 2 to the negative 2 power times 4 to the negative 2 power. And that would, then we would have to get rid of it and flip the negative exponents around. So it would be 1 over negative 2 squared times 1 over 4 squared. Or we could just say negative 2 times 4 is negative 8 to the negative 2 power. Okay, so then if we do it this route, then all we would have would be 1 over negative 8 squared, which would be equal to 1 over 64. that might be an easier way to solve this one. So either way, you would end up getting the same answer, because that would equal 1 over 64. Okay, so now the algebraic example would lead us to x and y being different, to the power of n is equal to x to the n power, y to the n power. And then you do whatever you need to. So there you go. And the last property of exponents is the power of quotients. Quotients are fractions, so same principle, just fractions. So my first example, I'm going to put my -2 into each one. And I have -3 to the -2 power over 10 to the -2 power. Well, now, since these are negative exponents, I need to flip them and then drop the negative signs. So since they're both negative exponents, I'm going to flip both of them, and I'm going to get 10 squared over -3 squared. And now I can easily simplify this. 10 squared is 100. -3 squared is 9. So that would be your final answer. And the next one, 2 to the 10th, 3 to the 10th. 2 to the 10th power over 3 to the 10th power. And if you type this one out, you're going to get kind of a weird number. So since they are large exponents, I want you to just leave them like that, and it'll be simple. And my algebraic example here is if we have x over y, and we're taking all of that to the n power, we're going to get x to the n power over y to the n power. So you just put the exponent into each one, and then you simplify. So those are the notes on the properties of exponents. We'll go over a few more examples in the next video, but you should be able to do some practice problems. And then once you watch the next video, you should be ready for your quiz.